Hello guys, welcome to today's video. In this video, we are going to talk about zeros of a polynomial. Uh, in previous video, we spoke about factorization, previous video, right? And there, while doing factorization, we spoke about that uh, while factorizing a polynomial, okay, uh, while factorizing a polynomial, for example, cubic polynomial, okay, so we just look for a value of x to initiate the division, right? So we always look for the value of x that can make the value of whole expression 0, right? So those values of x that can make whole polynomial expression 0 are known as zeros of a polynomial, okay? Or I can put it this way, okay? Uh, if we have cubic polynomials, okay, we are going to have three factors, right? Let's say this is my these are the factors x minus 1, x minus 2, x minus 3. Okay, these are the factors I got for a cubic polynomial expression, okay, on division, okay? So it means that the value of x is going to be positive 1 or positive 2 or positive 3, right? So x is going to have three values, which means that if you are going to put any of these values in the main polynomial expression or dividend, the value of this whole expression will get 0. Okay, so these values of x are known as zeros of a polynomial. Okay, so simply I can say that, okay, I can define zeros of a polynomial as the values of x that makes px 0 are zeros of a polynomial. I hope this thing is clear to you. Okay, this thing is clear to you. Okay, now, because as we know that polynomials are of different types, right? We spoke about constant polynomial, degree 0 polynomial, or degree 1 polynomial, linear polynomial. We spoke about degree 2 quadratic polynomial. We spoke about degree 3 cubic polynomial, okay? So zeros of a polynomial depends on the type of polynomial. It means that to find the zeros of different types of polynomial, we have to study we have to study the different types of polynomial too, right? And we'll see how the zeros of a polynomial uh, is going to work, right? And on what factors uh, does it depend, right? So we can start with the first type of polynomial, or zero degree polynomial. Okay, so see here, zero degree polynomial. It's also known as constant polynomial. Okay, constant polynomial. Okay, constant polynomial. Okay, now the general expression to represent constant polynomial is px equal to k, where k represents the constant value. Now as you can see that this polynomial expression, it contains only one term. For example, px equal to 7, right? px equal to 7. So it contains just one term, and that term is independent of x. So it means that the zeros of polynomial does not exist for constant polynomials. Okay, so I can say this is degree 1 polynomial, sorry, degree 0, n equal to 0, degree 0. So I can say here zeros do not exist. Is that clear? Okay, so if it is clear, let's move to the next. Next is our linear polynomial. Okay, linear polynomial means degree 1. The general form is px equal to ax plus b, where a must not be equal to 0 and a, b belongs to real numbers, right? So let's see. Now, as you can see here, this is degree 1 polynomial because the degree of x is 1. Okay, so in linear polynomials, we are going to get 1 0. Okay, in linear polynomial we are going to get 1 0. Okay, uh, we'll find out the 0 for this linear polynomial. Okay, so can I say that let alpha be the 0 of px? Okay, so I just wrote the equation. This is the general form to represent linear polynomial, and here I said let alpha be the 0 of px. Okay, now if alpha is the 0 of px, then what would happen? Then p of alpha would be, I have to replace x by alpha, right? A alpha plus beta, and px must be equal to 0. Sorry, p of alpha must be equal to 0, because we see here zeros of polynomial means those values of x that can make this px 0. So here equal to 0. I hope you understand this thing, right? So now from here, if I take these two, okay, which implies a alpha plus b equal to 0, the value of alpha is going to be minus b by a. Minus b by a, right? So this alpha, it is 0 of linear polynomial. And this b, it is coefficient of x naught, and this is coefficient of x, right? A is coefficient of x and b is coefficient of x naught. Because this is constant, so I can write here b multiplied by x0, right? So the 0 of any linear equation can be found by this formula. Okay, you can implement this formula in any linear equation, it will work. For example, 3x plus 2. Okay, this is polynomial expression and you have to find the 0. Okay, so I will just put the formula, let alpha be the 0 and the value of alpha would be minus b by a. Now see here, this is ax plus b. So a means 3, b means 2, minus b by a, 3. Now let's find the 0 by other way. Okay, so 0 means the value of px is going to be 0, right? So 3x plus 2 equal to 0, x is equal to minus 2 by 3. Now you can see Now, alpha means the value of x, so it's the same thing. I hope this thing is clear to you. Okay, now let's move to the next. The next is our degree 2. The next is our degree 2 polynomial. Degree 2 polynomial. So number 3 is our degree 2 polynomial is quadratic polynomial. Okay, here I am going to summarize everything for linear, and here zeros. For linear, it will be alpha is minus b by a, right? Okay, now for quadratic. Okay, now see here, the general form of quadratic polynomial is px equal to ax squared plus bx plus c, right? Where where a must not be equal to 0, a and a, b, c real numbers, right? And also n is 2. Okay, n means the degree. Okay, now see here, now quadratic polynomial, they have degree 2. Okay, it means you are going to get two zeros, right? Quadratic polynomials have degree 2, so you are going to get 2 zeros. Okay, so let's say that alpha and beta are the zeros. Okay, because it's going to have two roots. So here I just said that I have, let's say it's my supposition that alpha and beta are the two zeros of this quadratic polynomial. Is that clear? All right. Okay, now I'm taking one example here just to make things little clear for you. Uh, Let me take one quadratic polynomial expression example. Okay, uh, 2 x squared plus 5x plus 2. Okay, now if I have to find the solution or zeros. Now see here, one more thing, that sometimes zeros of a polynomial are also known as solutions. Not sometimes. In some of the books, they have used the term solutions. In some books, they have used zeros. The meaning is the same. Okay, so don't worry that you didn't have seen this term before, so it might mean that the meaning has changed, or something new has been introduced. So do not worry. Okay, so the meaning is same. Now I have this quadratic polynomial. Okay, now if I'm going to split the middle term of this polynomial, because I'm interested in finding the zeros of this polynomial, means the values of x that can make this expression 0. Okay, so what I can do is I am going to split this middle term. So can I write 2x squared plus Now see here, when you split middle term, you have to split this thing into, you have to split constant part of this term into two terms, okay, two constant numbers, so that the sum is going to be this, and the product, and when you multiply, the product should be equal to 2 multiplied by 2, 4. Okay, so it's going to be 4x plus x. Okay, here 2. Okay, if I further simplify it, it would be 2x. I will take common here, and here will be x plus 4, x 2x common, so here x plus 2, and here 1 x plus 2, right? So I can say 2x plus 1 and x plus 2. Now what I will do here, I will take 2 common out, and it would be x plus 1 by 2 and x plus 2. Is that right? Do you agree? Okay. Now see here, if I have to find the values of x, so the values of x here are going to be x plus 1 by 2 equal to 0, which means x minus 1 by 2, and here x plus 2 equal to 0, which means x is going to be minus 2. Right? Right. So if this value is alpha, and if this value is beta, okay, if this value is alpha, this value is beta, so can I write here these two can be written as k constant, right? And can I write here x minus alpha and x minus beta? I hope you agree with me. Okay, I can write, see here, the value of alpha is minus 1 by 2, so minus minus plus, so it's the same thing, right? So now see here, my my whole purpose to do this was to let you understand that can I write for this expression, a x square plus bx plus c equal to k constant, x minus alpha and x minus beta. Why? Because this is quadratic polynomials, it's going to have two zeros, so I said this whole equation is equal to k if it has some constant multiplied to x minus alpha, x minus beta, because sometimes the factor is like you have to take something common out, so this k represents the constant part. Understand? So alpha and beta, they are zeros. Okay, now if we solve it, what would happen? If we solve it further, then can I say k? Now you have to use which property? You have to use distributive property, right? So it would be x square minus x beta minus, again, distributive property, alpha x plus alpha beta, this bracket. Right, now it will be equal to k, so here x square minus, can I take x common from here? If I take x common, can I write here alpha plus beta? Agree? If I write here alpha plus beta is the same thing, okay? Plus alpha beta, alpha beta. And on the left side, I have ax squared plus bx plus c. Okay, now just see here. Sorry. Now see here. Here you have coefficient of x square. Here you have coefficient of x square. Here you have coefficient of x. Here you have coefficient of x. Here you have constancy. Here you have constant part. Okay, so can we compare the values? Okay, on comparing, here I'm writing on comparing. Okay, on comparing. Okay, if we compare, what will happen? uh, on comparing this, see here what will happen. uh, the value of a is going to be k, or can I write k will be equal to a? It's the same thing, right? Because this a, and here you have 1 k multiplied by 1 k, so k. Or I can further simplify it. Okay, wait, I can just multiply this k here, k x square minus xk, and here k plus alpha beta k. Okay, then now see here k, then compare this one. So can I write b is equal to minus k alpha plus beta, right? Agree? So can I say alpha plus beta would be equal to b, b by minus b by k? Or can I say alpha plus beta would be equal to minus b by k? The value of k is a, so can I say a? Why am I doing this? The question can come to your mind, because my purpose here is to relate the roots with the coefficients, because sometimes they can ask you that, sorry, not roots, zeros. Okay, sometimes you may see the question that are you are given with zeros of a polynomial, and you have to make the equation, you have to make the expression from the zeros of the polynomial. Or sometimes you may see the question which says that they will give you some condition on the sum of zeros and product of zeros, and then they will put some unknown thing here, or unknown variable here, right? Unknown variable here, and then they will ask you to find the value of that unknown quantity. Okay, so you must know these things. All right, then compare the last one. So this would be c would be alpha beta k. So can I say alpha beta, it would be c by k, which is alpha beta is c by a, because k is a. So this result is also very important. Okay, so I hope this is clear to you. Okay, now see here, sometimes you may see questions where they will give you the zeros of polynomial, and you have to make polynomial out from it. Okay, now I can erase this. Okay, Here I am writing formation of quadratic polynomial. Okay, now see here. First we will derive the formula for it, because if I will write the formula, the next question would be how did we get it. Okay, so let me go there step by step. Okay, for example, bx is ax square plus bx plus c, right? Okay, if now see here, you are given with a, this is a quadratic polynomial expression, right? So we are finding the zeros, right? We are finding the zeros of this quadratic polynomial expression. Okay, so what would happen? See here, can I equate this ax squared plus bx plus 0 is equal to plus c is equal to 0, right? Now what I will do here, okay, here I'm writing, I'm dividing by by dividing by a. Okay, I'm going to divide this whole expression by a, so it will be x square plus b by a x plus c by a, right? So equal to 0, right? So can I write here x square plus b by a? What is b by a? Minus of alpha plus beta, right? Can I write here minus alpha plus beta x, and c by a, can I write alpha beta? Okay, so now see here, if you are given with the zeros of a quadratic polynomial expression, you can make a polynomial expression out from it. Okay, you just need to remember this. This is the formation of quadratic polynomial. Okay, let's take an example. Find okay, I'm just going to speak the problem. Okay, find the polynomial expression whose zeros, whose two zeros, okay, whose two zeros are, or find the quadratic polynomial expression whose two zeros are are 5 and 2. Okay, now you have to find a quadratic polynomial expression. You are given with the zeros 5 and 2. Now see here, it's simple, just use this formula. So the expression is going to be px x square minus alpha plus beta x plus alpha beta, right? So this is alpha, this is beta, right? So it would be x square minus 5 plus 2x plus 10. So it will be x square minus 3x plus 10. So this is going to be your quadratic polynomial. I hope you got it. All right. If you got it, we can have some questions for it, or do you want to do it later? Okay, later is fine. We are going to discuss one more type and then we'll summarize it. Okay, so Okay, so the next is our degree 3. Okay, and degree 3 is next is our here zeros for quadratic is what did we learn? Alpha plus beta minus b by a and alpha beta c by a, right? Now next is this thing is separate. Okay, now next is our cubic polynomial. Now see here, cubic polynomial general expression is bx is ax cubed plus bx squared plus cx plus d, where a is not equal to 0, a, b, c, d belongs to real number. This we know, right? Now, uh, now let's say uh, let's say that alpha, beta, and gamma, right, are three zeros. Why? Because degree is 3, right? Because degree is 3. So let's say is that these are the 3 zeros. So if you remember in quadratic, what I did, I just equated, I just equated whole equation to the general form equation of quadratic polynomial with k constant, x minus alpha and x minus beta. So here we have 3 factors. So can I say ax cube plus bx squared plus cx plus d, which is going to be k constant, x minus alpha, x minus beta, and x minus gamma. Okay, alpha, beta, gamma, there are 3 zeros of this cubic polynomial. Okay, now what we'll do from here, k here, if we know it because we did it before, so it would be minus alpha plus beta x, and here alpha beta, right? Yes, and here x minus gamma. I hope I didn't do any mistake here. I think so. Okay, then here again k common, and here if you apply this distributive law, right, so it would be x cube minus alpha plus beta x squared plus alpha beta x minus x squared gamma minus alpha plus beta x gamma plus alpha beta gamma. Okay, alpha beta gamma, and here the main bracket. So if I simplify it, x cubed minus x squared, and I see here alpha plus beta here, and here here x squared minus, oh, it's gamma. It is gamma. Okay, can I write here alpha plus beta plus gamma, right? And here what I did, if you don't understand, I just took x squared common out, right? And I'm dealing with these two terms with minus sign. So here minus sign is common, that's why positive. And here x common, so alpha beta from here, and from here alpha gamma, alpha beta this is minus, 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 plus. Oh, what I did. Minus, minus, plus, and this is minus. Alpha, beta, plus alpha, beta. I'm dealing with these terms. Alpha, beta, sorry. I can use this blue, alpha, beta, and here, this one. Okay, so alpha, beta plus alpha, beta plus beta, gamma, and alpha, gamma, alpha, gamma. And here in the end, just minus alpha, beta, gamma. Okay, now on this side you have ax cubed plus bx squared plus cx plus d. Okay, now comparing the terms both sides, what will you get? See here this a will be k, right? I'm just comparing. So now I'm comparing the terms with variable raised to the power 2. Okay, x variable raised to the power 2, so it would be b is equal to minus of alpha minus of k, because k will be multiplied alpha plus beta plus gamma. Okay, which implies alpha plus beta plus gamma is equal to minus b by k, and which implies alpha plus beta plus gamma is minus b by a, because k is a. I hope you agree, right? Now next, compare compare the like terms. So here what you will get, alpha beta plus beta gamma plus alpha gamma equal to c by k, because k is multiplied to this term. So alpha beta plus beta gamma plus alpha gamma would be c by a. Okay, and the last is alpha beta gamma. Alpha beta gamma will be equal to minus d by k. So alpha beta gamma will be minus d by a. So from here you can see how the roots are related to the coefficients. Is that clear? Yes or no? Okay. Now, so the sum of roots is this, and this is alpha beta plus beta gamma plus gamma plus alpha gamma, that will be equal to c by a, and alpha beta gamma would be equal to minus d by a. Now see the formation of the polynomial. I think I can erase it, right? So see the formation of the polynomials, formation of cubic polynomial. Okay, cubic polynomial, and here I'm writing here formation, okay, formation. So simple, what you can write here is, the formula is x cube minus alpha plus beta plus gamma x square plus alpha beta plus beta gamma plus alpha gamma x, right? And here minus alpha beta gamma. Okay, so this is going to be the formation of cubic polynomial. Okay, and how did I do it? So it's simple. The same equation, general equation, ax cubed plus bx squared plus cx plus d equal to 0. What you can do is divide both sides by a. So x cubed plus b by ax squared plus c by ax plus d. Then what you can do is you can just put in these values, b by ac. So it will be x cubed here, b by a means minus alpha plus beta plus gamma x squared plus c by a, this one, alpha beta plus beta gamma plus alpha gamma, and here d by a, d by a, yes, d by a. So d by a is alpha beta, d by a is minus of alpha beta gamma. So if you see this equation, it is quite similar to this one. Okay, now if you are given with 3 zeros, you can make cubic polynomial out from it. I hope this thing is clear. Now we are going to take some questions. So here, if I have to summarize cubic, then you can write it here. Okay, so that if you just look at it once, you can figure out the difference. Okay, you can do the same for quadratic too. Okay, you can say that, let's say that alpha beta gamma and some other quantity are the zeros, okay, of biquadratic polynomial. Then take k with them and then multiply and then compare. Okay, so this is quite easy, right? Let's take some examples, not some examples, but some questions. Let's take some questions. Okay, question 1 says, can I raise this too? All right, it's of no use. Okay, so the question says that find zeros of x squared plus 7x plus 10 and verify relation between zeros and coefficients. Quite easy. Okay, now see here. So you are given with this is our quadratic, right? And then you have to verify relationship between zeros and coefficients. So first you have to find the zeros. Okay, so px, can I write px equal to x squared plus 7x plus 10? Okay, now here, can I say, if I compare this one with ax squared plus bx plus c, can I say a1, b7 and c10, right? 10, right? Now this x squared plus 7x plus 10, if I have to find the zeros of this polynomial, what I need to do, I have to check for those values for x, which makes this whole function 0, right? So can I say x squared plus 7x plus 10, can I split the middle term, x squared plus 5x plus 2x, I'm just factorizing it, I think you know it, x plus 5 and here plus 2, x plus 5. x plus 5, x plus 2 equal to 0, equal to 0. Right? So, because we are finding the zeros, so this equation, this expression must be equal to 0. Okay, so the value of x would be minus 5 and x equal to minus 2. So value of x is minus 2 minus 5. Now see here, this is quadratic polynomial, and alpha plus beta should be minus b by a product c by a, right? So we have to verify the relationship, right? So this is the relationship. Now see here, alpha plus beta. If you say this is alpha and you say this is beta, so alpha plus beta will be minus 7, which is equal to minus b minus 7 by 1. So minus 7 equal to minus 7. Alpha beta is c by a. So alpha minus 2 multiplied by beta minus 5, which is 10. So c is 10. So means this is true. Okay. So you may see these kind of questions. Okay. I hope this is clear. Can I erase? All right. Next is next question says, if alpha and beta are the roots, sorry, not the roots, but the zeros of x square minus x plus 1 p plus c such that alpha plus beta and beta plus alpha plus 1 beta plus 1 equal to 0, find c. Okay, now see here, you are given with this polynomial expression. This is quadratic expression, so I can write here px equal to x squared minus x plus 1 p plus c. Okay, now plus, okay, now I have to find the value of c. Okay, so I will simplify it. Let me see if I can. X square minus bx minus b plus c. So can I write x square minus bx plus c minus b? Now see here, this is c minus b is the constant part like ax square plus bx plus c. So this is the constant part, right? Now see here, alpha and beta are the zeros. Okay, so alpha and beta are the zeros of this equation, which means alpha plus beta should be minus b by a, right? So alpha plus beta will be, what is b? B is minus b, so it will be b, right? A is 1, and alpha beta will be c by a, right? C by a, which is c minus b. Okay, so can I say alpha beta is c minus b? Now it says alpha plus 1 beta plus 1 equal to 0. Okay, so I think we can make use of this. It will be, if we multiply alpha beta plus alpha plus beta plus 1, okay, equal to 0. Alpha beta is c minus b plus alpha plus beta is c by alpha, sorry, alpha beta is c minus b, and alpha plus beta is b, which is equal to 0. So plus 1, right? So this is minus b, so the value of c is going to be minus 1. I hope you understood, right? Okay, alpha beta plus 1. Yes, alpha beta c minus b plus p. P, yes, it's correct. C minus 1. Okay, let's take one more question. Let's take one more question and we'll summarize this session. Okay, so it says question number 3, find k such that x square minus k plus 6x plus 2k minus 1 has sum of its zeros equal to half of product. Okay, let's see this one. This is given expression, so I can write here bx x square minus k plus 6x plus 2k minus 1, right? Now it has sum of its zeros equal to half a product. So let's find, that's alpha and beta, two roots, because this is quadratic, so it will be minus b by a. So minus b means k plus 6. So alpha plus beta, k plus 6, and alpha beta is c by a, which is 4k minus 2. Now it says sum of its zeros. Sum of its zeros means alpha plus beta is equal to half of alpha beta. Okay, so let's see. Alpha plus beta means k plus 6 is equal to half of 4k minus 2, which implies 2k plus 12 is equal to 4k minus 2, which implies 12 plus 2 is 4k minus 2k, which means 2k equal to 14, k is equal to 7. So the value of k must be 7. Okay, so you may see these kind of questions. Okay, it's always good to learn the things that you can analyze, because these zeros, I mean, the main purpose is because when we are going to sketch the graphs, then we have a clear understanding of everything. Okay, so that's the main purpose. Okay, it's not about, like, just do the things that are in the books. Sometimes you need to go off topic to explore the horizons, right? So I hope you got it, and next time, in the next video, we are going to start with sketching the graphs. Okay, so thank you very much, and have a great time. Bye bye.